All right, I'm recording.
Yeah. Okay. Hi, Ryan. Welcome. Hi, Philippe.
Hello, guys.
Hello.
Hello. Welcome.
Everybody.
Welcome.
Ring.
Hi, Sinu.
I'm joining from a bunk bed in Taiwan, so you guys know.
You're on a bunk bed in Taiwan, did I hear?
Yeah.
Nice.
Yeah, the ZK Hacker House put us up in like a 20-person hostel, like 10 bunk beds.
Nice.
And are you top or bottom? I propose we wait 1 more minute and then get started.
I'm not sure if I'm the only one, but I cannot hear you very well, Henrik.
Better?
Yes, that's much better, thanks.
I have to learn to speak into the microphone.
Hello, everybody.
Hi, Charlie.
Hi.
Okay, it's 6 o'clock somewhere, so I propose we get started. Welcome to the cafe hour. This is again a weekly session with our community from PSE. So this is a perfect opportunity for questions and feedback. Note that this session is recorded. On the agenda today, we have TLS Notary and data portability. So I propose we start with updates from the TLS Notary team, what we've been working on, and what you can expect next. And then once we get through that, we open the mic for questions from everybody. Let's try if it works by just interrupting us by unmuting. If that doesn't work, then I propose, or it gets too chaotic, then I propose we type questions in the chat and then I will unmute you so that we can get some order if necessary. Yeah, so maybe a quick shout out to the TLS Notary people in the group. So we have the green frog crab, that's Sino, our technical lead. And then I also see Chris, Dan, Thomas. I don't see Tsukino yet, but I see Trauma or Tanner, who also joined the team. So let's get started. Maybe first, Sino, can you give an update on what was new in our latest Alpha 4 release?
Sure. Yeah, so I think we released Alpha 4 either, 2 or 3 weeks ago now. Don't remember the exact date, but it had some fairly large features in it. One of which is called deferred decryption. The gist of this is that TLS Notary is a network-bound interactive protocol, so it involves a lot of communication between the prover and verifier and prover and notary. And deferred decryption essentially just reduces the communication that's required in order to prove some data by deferring decryption until after the TLS connection is closed. And we're able to just use a trick there that which lets us use just ZK to decrypt the server response data as opposed to using full-blown MPC. Additionally, we exposed more in our API. So now, again, the prover and the notary, or you could call them the MPC TLS verifier. Once they've completed the TLS session with the server, the prover is holding commitments to the server data, and we've just exposed in our API the ability to just directly reveal parts of the data to that party. So you can just reveal things directly off chain without having to go through a separate process afterwards. For example, if a notary signs the blind commitment to the data, normally you have to go through an extra step to generate a proof which reveals parts of the data. The interactive verifier feature just lets you do that directly in the same process. And we also made some changes to the API for selective disclosure, mostly around making it easier to generate commitments to HTTP data. So I think our first API was really just you specify ranges in the transcript, but that's not very ergonomic because now you're dealing with regex or statically specifying ranges in the data that you want to commit to. So yeah, we've redid our API, which allows you to just specify like header names, and it also supports JSON at the moment, and we'll be adding more data formats in the future. And that's most of what was in Alpha 4 as far as the core library goes.
Thank
Would
you.
someone like to? Yeah, go ahead, Hendrik.
Yeah, I was going to ask if there are already specific questions about what Sino just said. Don't be shy. Okay, then we move on to the browser extension. So that was also updated for Alpha 4. We also did some internal cleanup. And it's also worth mentioning that we added also a quick start for using TLS Notary in the browser. So depending on your plans, that might be a good place to have a look. There is not really updates from the public notary server that we run, except maybe it's a good time for a reminder that so the PSE hosted notary server is for testing purposes only. So you can use it to test and bootstrap your application, try out stuff. But please don't build your business on it. We don't want to be responsible there.
Have you guys got any people trying to abuse it yet, or no?
Well, so it's mainly used for in hackathons for the quick start and also for internal testing. I'm not aware of people using it in for on higher bandwidth applications yet. So we still have lots of room on the server side, so it's still underused at the moment. So that was a quick update on the past. So maybe it's interesting to also have to hear what upcoming improvements we can expect. So first thing is odd decode. Sino, do you want to give an update there, or maybe Dan or Chris?
I can give like a high level summary of what's coming up, both near term and further term, without dragging on too long about it. So our near term focus is really just on supporting applications that want to do on-chain proofs. So for example, in the Notary configuration, you have a signature on some commitment to data that you queried and got a response to off-chain, and now you want to do something with it on-chain. The commitments that we support right now aren't able to be efficiently opened on-chain. It involves a lot of data. So we have a protocol called auth-decode, authenticated decoding, and essentially what it lets you do is during, for example, the notarization process, you can convert these commitments into commitments which are more efficient to use in zero-knowledge proving systems. So auth-decode specifically is going to give you a Poseidon hash commitment to the server data, for example. So then you'll be able to write yourself a circuit with your DSL of choice that does some sort of selective disclosure, and a public input to that circuit will be a Poseidon hash commitment to the data. And it'll be up to you to figure out what the actual circuit logic is to prove that with integrity, but at least we'll have a start, or you'll have a commitment that you can actually use. But yeah, just the more general thing there is just supporting doing on-chain proofs with this stuff. It's everything, selective disclosure and all that is quite doable off-chain today, but again, lots of people that want to do things on Ethereum, obviously. So that's near term. That's our primary focus right now. We do have a bunch of low-hanging fruit regarding performance improvements. So that's another thing that we need to get down. So the protocol, like I mentioned before, is both network bound and it's highly interactive. So there's some things we can do, one of which is we can just move more of the MPC computation to before the TLS connection's even opened. We do most of that in the prior phase right now, but there's more pre-processing that we can do. And the impetus there is that if it takes too long to do that in the online phase, the server sometimes closes the connection. It's not patient enough to wait for us to like encrypt the request, for example. And yeah, we've also been doing a little bit of profiling, and we're pretty sure that the round complexity of the protocol is higher than it needs to be. So when you have a high latency connection, that really affects proving performance. And yeah, I believe we're going to be able to bring it down at least 2x. It's hard to say. It all depends on network conditions and things like that. But yeah, there's definitely some low-hanging fruit there. And on the longer term, once we've kind of got a good story for, I guess, on-chain proofs and being able to do selective disclosure there, we have more performance improvements that we want to do, one of which is just upgrading the ZK proving system that we use for the protocol internally. So right now we use garbled circuits for zero-knowledge proofs within the TLS Notary protocol, and they are very bandwidth expensive as well. So we have it on a roadmap to switch to newer interactive zero-knowledge proving systems that are about 100 to 200 times more bandwidth efficient than that, and that will allow us to really like bump up the total amount of data that you're able to prove. So right now you're kind of looking at low kilobytes. Under 10 kilobytes will be pretty good experience, but as soon as you start getting past that, you're going to be waiting. Once we upgrade this proving system in our internal protocol, you'll be able to start looking at proving on the order of megabytes. But that's again, that's going to be coming later in the year. And once we've got that in place, we will be looking at exposing this proving system too. So in the off-chain scenario, when you're wanting to disprove off-chain, you'll be able to leverage this proving system backend that we use internally. We'll expose an API, so you'll be able to do selective disclosure using it as well. And I think that's most of what we have on our mind right now for core protocol.
Is that interactive that upgrade to your internal proving system? Is it like, are you guys going to create something new, or is there some? Can you give me like a name? I could like look it up or something.
Quicksilver. So it's a newer, more recent class of proving systems that are based on something called vector oblivious linear evaluation. It's a completely different type of proving system that you would expect what you see in snarks that are based on elliptic curves and things like that. Because it's interactive, well, not because it's interactive, but it's not succinct, and it requires interaction. And with those concessions, in the off-chain scenario, it's extremely efficient. You're talking about like linear memory requirements and things like that. And it's really good. Quicksilver is the name to look up.
Thanks, Sino. There were a few questions already. Maybe I read them out loud. So Chiali asked, is there a doc for that already? I think that was when odd decode was mentioned. So odd decode is not merged yet, but maybe Dan or Chris, do we have some documentation already?
Regarding odd decode, I
Yes.
would say no. We used to have like a description, but we changed it up, so it's not up to date. Yeah, but as soon as that's part of the the PR that I'm working on. I'm going to be providing a comprehensive explanation of what the protocol does. Although we simplified it and it's very simple right now. Yeah.
Perfect. Something to look forward to. Then, I'm not sure if I pronounced it correctly, Wi-Fi Yes asked if will the hash be of the encrypted data or of the decrypted data?
It will be of the plain text data sent and received to the server. And the hash itself will be obviously blinded.
Wi-Fi Yes, does this answer your question, or you can also unmute and ask follow-up questions?
So I was wondering then, how does the notary get the plain text data, like if it has to produce the hash, because it's involved in MPC. So
Yeah, so during the TLS session, the prover gets commitments to the plain text data, and in such a way that the notary doesn't see it. And then the OptiCode protocol converts these commitments to a different kind of commitment, which is the Poseidon hash. And we do that using a zero-knowledge proving system, which again preserves the privacy. So at no point is the notary ever going to see the plain text. They do, of course, see the ciphertext, so they are aware of the length of the messages, but not of the text content itself.
Okay, and then there was also a question for which proving system was used. So that was Quicksilver, and Thomas also shared the link to the article on ePrint. So that's also some homework to do, maybe. Next up, another thing we're working on is we're building an explorer or a visualizer for TLS Notary proofs. And Tanner, you prepared a quick demo. I hope screen sharing works on Discord. Let's give it a try.
Yeah. This will be quick. I'll give it a second for people to join.
Can everybody see the shared stream?
Yep.
Perfect.
Yes.
All right, cool. Well, yeah, this is the Explorer. If you've messed around with TLSN before, you've probably seen the proof visualizer that we already have, but we are rewriting it just to make it, I guess, more robust. But you can drop your proofs in, and you can see all of the data that the proof contains, and you can also share your proofs. They get pinned to IPFS, and you can share your proofs. People can view them. Yeah. Any questions about the Explorer at all, feel free to ask, but that's about it for the Explorer.
Smooth.
Could you give like a quick summary of what the, I guess, end-to-end flow there is? Like why do we have an Explorer and what can it be used to do?
Well, we want to do a few things with it. We want to do integrate like a plugin system using XTism for it, so other people can provide like their own proving system and their own like, well, I guess not verifying, or yeah, their own verifier for it, and can verify it and prove their own proofs. But for right now, it is just a proof visualizer.
So the high level idea there is you query a server, you get a signature from a notary on that data, and you need some way to be able to distribute that data. One way to do it would be to email a proof to someone. But the Explorer is kind of being an in-between utility there, where instead you could give someone an IPFS link and they can pull it up in their browser, and the browser contains the code to do local verification. So yeah, the high level idea here is just make it easier to just share proofs with other people. And Tanner, you were saying that, I guess, plugin system as well. So the one thing that the Explorer does right now is you can just do a very simple selective disclosure where you reveal a substring of the data, but you can imagine that you want to do more complex proofs with it than just revealing parts of the text. You might want to prove things about the contents of hidden text. So with the plugin system, you'll be able to write your own, like integrate your own proving and verification logic and distribute that as well.
And so this new Explorer is written in TypeScript so that it's easier for all of us to extend it and improve it, to reuse parts, whatever is useful to you. Any questions on the Explorer or on the browser extension that we have for TLS Notary? Okay, then, oh, there is one. Maybe you can unmute and just ask the question, Josh?
Yeah, so like in the Explorer, we saw that there are some parts that were like in plain text, while others were like XXX redacted. So, so is it more cheaper to have a lot like things? Let's say if we bunch up everything in plain text and together, whatever needs to be in plain text together and whatever needs to be redacted together in the HTTP response headers. Like does that reduce the complexity, or the number of redactions is like independent, like it doesn't affect complexity? Like, did I make sense?
Yeah, I think I understand your question. It's not that much of a factor, is the simple way to put that. In the end, it's going to depend on what kind of commitments you have. But at least for the commitments and the technique that we're using right now, just for simple redactions, it's essentially just a Merkle proof that you can batch. So in order to reveal some substring, you essentially just have to provide that substring, and then you have to provide a Merkle inclusion proof. But for redacting the data, that's free. You just simply don't provide that information. But yeah, it doesn't really having multiple partitions like breaks in the text that it really doesn't increase complexity all that much.
Yeah, thanks.
Okay. Then other news and updates from TLS Notary. So there are a few events on the agenda. There was also one that just was last week. So Chris gave a very nice presentation on TLS Notary in Kuala Lumpur. So if you follow us on Twitter or Farcaster, you might have seen it already. So it was recorded and posted on YouTube. So if you haven't seen it yet, I definitely recommend to give that a view too. Then for upcoming events, next month, April, the TLS Notary team is traveling to Amsterdam for EDAM, where we have lots of plans. So first, there is a presentation on TLS Notary. We are also sponsoring a prize at the hackathon. So if you're in Amsterdam at that time, I think there's still time to register. So yeah, there you could hack to win a TLS Notary prize if you have a project that uses TLS Notary, of course. And we also plan to have some fun ourselves. So we also subscribed for participating in the hackathon ourselves, but in a special track, in the Otter track. And so that's kind of outside of the main competition. But it's a track for existing projects. And so we also want to hack together. And the plan is to add a new feature to TLS Notary in just a weekend. So we're still planning this, but this will be exciting. We're really looking forward to this. And then also, as announced on our Discord, after EDAM, we will move to a different location together with 10 early adopters of TLS Notary. Where we will sit together in a shared space to work on TLS Notary and the TLS Notary applications together. So that's an exciting opportunity for us to network and get feedback, work on TLS Notary and shape the future of our project. So that's a very exciting month, April. And then a bit further in the future, there is ETH Global Brussels, where we will also participate in the ETH Global Hackathon. That's the weekend after ETHCC. And the only thing that's then planned for now is then DEF CON, of course, the end of the year in Southeast Asia. So yeah, exciting stuff to look forward to. And then maybe one special mention to. So Ryan just had to leave the call, but he worked together with Jomo on an Ethereum Foundation grant using TLS Notary, where they prototyped TLSN on-ramp or D-ramp, where they used TLS Notary to onboard people on-chain and exchange fiat for crypto stable coins. Very exciting project. And it was also the first time I saw TLS Notary used on mobile. So that's also good news that all of that works. So that was the all the topics I could think of that were useful to share with you guys. So maybe we do a first of questions again first. Did this trigger any questions from any of you? Don't be afraid to unmute.
I got one. So I'm curious what you guys going to hack together in Amsterdam as a team.
That's not decided yet.
Okay. All right, I'm too early.
Yeah. We have plenty of ideas, but only limited time, so we'll have to choose.
What was the most interesting project you guys see from all these hackathons so far?
Oh, it's always difficult to pick favorites. So I just mentioned TLS on-ramp because they started at the hackathon and then continued their work on it. So they are definitely the most advanced, I think, that I know of. But we also had some projects that we didn't expect. So, for example, there was in New York at the hackathon, there was a Zero Trust Bounty that used TLS Notary in a way that we couldn't have thought of ourselves. So just to have a fair marketplace to kind of disclose vulnerabilities in websites and then make sure that also the white hat hackers get rewarded for reporting that. So that was a very innovative use of TLS Notary. But maybe it's a good idea to do a tour here of all the people listening in. So who is actively using TLS Notary in a project right now?
Yeah, actually, that's a great idea that you asked this because it would be nice to have like some user cases, as you said. Sino is commenting all our users are asleep.
Yeah, Nina, I thought you were working secretly on a project.
Yeah, definitely. I am a very, very big developer, like a hidden one. But yeah, like I'm very curious to understand because I'm not. I haven't got such a technical background. Like if you can give some examples of user cases where people, as you said, if nobody wants to give an answer to Henrik's question, I would like any examples to to understand a bit more.
But maybe I can go through the names as I see them on my screen here. And then if you feel comfortable with it, just tell us what you're doing with it. So Chiali, I know you're not building, or am I wrong?
No, the only thing I do is t-shirt design for you guys.
I think she printed the code on the T-shirt.
Okay, then I have Daehyun. No, okay. Yeah, Dan is building TLS Notary itself, so maybe Philip?
No, not really. I'm here just to learn.
Ah, okay. Jake?
I am not, but I actually did just think of a question. Have you seen anyone try to use TLS Notary for more like Oracle oriented things? So is I getting off-chain data on-chain, and I assume there would be trade-offs with using TLS Notary versus say something like Chainlink or Dfinity. I think is another big one.
Yeah, so I've seen, well, actually, a lot of people come looking with the Oracle use case in mind. The first thing I always say is that one, TLS Notary is not an Oracle protocol itself, which some people think it is. But also the benefit of using TLS Notary for data which is public is very limited. So if something can be queried just by anyone online, such as like a price feed or any publicly available information, using TLS Notary in that process really doesn't provide all that much. There's some very narrow cases where you can prove that at a certain time that the server responded with something, but past that general public data, there's not too much there. But the part where TLS Notary is interesting from an Oracle perspective is that now you can prove non-public data, either data that is behind access control, such as something that like a API key gated service, or anything of that nature. In which case, TLS Notary is useful. But the thing there is that TLS Notary also doesn't solve the quote unquote Oracle problem. The MPC, yeah, the Notary or the MPC TLS verifier is still going to be a trusted authority in that process. So you can use TLS Notary, but you're immediately confronted with this issue where, oh, now I need to set up a committee and do some sort of consensus on top of that, so on and so forth, which is all totally possible, and people are interested and are looking at that exact use case. But yeah, just to clear up the confusion that often comes up there, it's not like this enables trustless like Oracle on chain. Yeah, and
right,
one way to make it one. Go ahead, Jake.
Oh, yeah, right. Because you have to want to, as you mentioned, trust that notary, but also you don't have some sort of consensus amongst end machines that that data is what the first Oracle purported to say it was. Right, as you mentioned. Yeah.
Right. It would be really nice if MPC were good enough to basically have multiple parties involved in this TLS multi-party TLS session. It is theoretically possible. There is a paper out there that basically demonstrates that this can be done, but the processing and communication requirements to do so is also enormous. And if the data volume, like the size of like the response is large, it really just enters impractical territory very quickly. So TLS Notary is a two-party protocol between approver and the MPC TLS verifier, Notary, whatever you want to call them. And yeah, so that off-chain MPC TLS verifier is always going to be trusted to not either just forge something themselves, they can sign whatever they want, or perhaps collude with the prover. One way to mitigate that is to just run this off-chain party in a trusted execution environment. And like a lot of people are starting to look more seriously at secure enclaves like SGX and so on and so forth. And the one benefit that TLS Notary would provide in that case also is that the privacy of the data, the privacy for the prover, doesn't rely on the secure enclave. Really, just the integrity of the attestation relies is bound to like Intel's signature, for example. So in which case, at least you have better guarantees about privacy for the users, but you still are always going to have like this off-chain trust component involved there. So.
Cool. Yeah, that all makes sense. Thanks for diving in.
Okay, next, Matty. You have a microphone?
I think he or she wasn't here before. They didn't listen to the
Hi,
question.
yeah, sorry. Hi, sorry, I just managed to unmute myself. Not yet. I'm not building anything yet, but I'm learning, and I will be at the Amsterdam Hacker House, so hopefully soon we'll be
Super.
building something.
Nice to meet you.
Yeah, nice to meet you as well.
Rachel, do you have questions?
I don't think so. I just wanted to drop in and learn.
Super, thank you.
Thanks.
Raphael?
Likewise. Thank you.
Senior?
Hey, I haven't. I'm still learning. I didn't know about TLS Notary half an hour before, so still going through the website. So yeah, my question would be too basic, but maybe perhaps next time. Thanks.
Yeah. Okay. Yeah, we probably went a bit too fast for you, but
Yeah,
welcome.
this is like nerd level 10. No offense. Like even the website, you go through it, and it's very not obvious what this is about. But now which section I finally found? Yeah, the motivation section is a little more. So that I'm going through this one now, and I think I get it, but not quite fully yet.
Perfect. Maybe then a quick question. How did you find us?
Thanks to Shiali, I just got to meet Shiali recently, and I saw this on Discord. Joined the PSC Discord. I just recently learned about ETH Sim, the project. This I understand more. And like years and years ago, I studied a bit zero proof knowledge and Zcash and this stuff, but that's been years, so it's a good refresher. But yeah, that's how I got here.
Nice, interesting.
Yeah,
Thanks
thanks
for
for coming.
Yeah.
Yeah,
Yep.
thanks. That's cool. Oh yeah, let's keep learning. Thanks.
Yeah.
Like if I understand correctly, the idea is just to like data provenance. I understand, but just to, like maybe one question is like how TLS, because I have TLS certificate for my website and like or just sites. I understand that, but by where and I understand Ethereum a bit, so these like enclave and stuff like that. But like if you could like in one sentence explain what does TLS has to do with it, you.
Okay, Sina, do you do it or do I?
Are you wanting to do it? You can go ahead.
Well, you're the big expert.
What TLS has to do with it is it's just a convenient existing cryptographic protocol that is already widely adopted on the internet. So the ideal scenario is that the server just signs the data directly, but servers don't do that. So we have all of these warehouses of data already sitting there and available. And the question is, how can we essentially prove the provenance of that when you query it? So TLS already exists basically every deployment on the internet uses TLS. Yeah, so you look at that and you go, okay, well, we got this. It uses cryptography. How can we mangle this thing sufficiently to get a proof of provenance out of it?
Yeah,
It
maybe
might also be a good idea to watch the recording of Chris' talk last week. So that gives a nice high-level overview of what TLS Notary is about.
Yep. That's like I said, I'm sure I'm missing most basic component. So, but thanks, thank you. I think I get a little more like, so why not use what's existing already instead of, and then somewhere I'll get the zero proof part. Yeah, I know. Anyway, thank you. Next time. Peace.
Okay.
Bye.
Then I see a few TLS Notary at BSE people. So maybe Yash?
So I haven't used TLS Notary. So I have attended the Istanbul session that TLS Notary had. There I built something with the team, but it was mostly the team building for me. I was asking for help. So that's one thing. And the second thing is like I've worked with the Reclaim protocol. So yeah, I built some. So Reclaim protocol is quite similar to TLS Notary. So rather than using MPC, it uses like it decentralizes the notary part and having proxies in place. So yeah, so I've used that. So I've built some interesting applications using Reclaim. So yeah, at some point I want to build using TLS Notary too.
Nice. Can you give an example?
Yeah, so using Reclaim protocol, there was like I've built one application, for example, was finding the citations of a person. Like so, the user can claim how many citations they have on Google Scholar. So that was one application. Yeah, that's one example. So
Okay, nice. Thank you. Other questions? So we're 45 minutes in. That's the time budget we allocated.
Sorry to interrupt you. There are two new people that joined us. Maybe they can tell if they're using already the TLS Notary. It's Eric and Eller. Am I pronouncing it correctly?
Euler, I think it's German, the mathematician. So Eric is with the EF, so I know Eric. So maybe Euler Lagrange. We're doing a tour asking everybody who is building what with TLS Notary.
Yeah. So, well, first off, I'm not actually German. I just studied physics, and my username is like my favorite equation from physics. But I've been obsessed with TLS for like many years now. I started a company like based around it back in the fall. And like we're building a mobile app that we'll be releasing soon, along with like a bunch of fun Farcaster frames. I'm also working with the EigenLayer team to set up TLS Notary nodes as a ADS. So yeah, I'm super excited about TLS Notary. One question I did have, I think like I've asked like Sinu about this in the Discord, is like the timeline for more ZK friendly notarizations.
Yeah, so we spoke to that a little bit earlier. Essentially, the OptiCode protocol is what we need for the commitments to it. Dan just opened up basically a PR, so we're starting the review process on the implementation of that protocol. We also have to work on integration into the like existing notary data structures and so on and so forth. It's taken a little bit longer than we initially thought, but certainly within the next month, we definitely want to have it ready for the hacker house, because I know that a lot of people are looking at on-chain use cases. That's just for the OptiCode integration. We're also going to need to, we're going to want to provide some I guess, Solidity examples for how to write a verifier as well. So yeah, both of which we're definitely gonna, I mean, it's highest priority at the moment, so it's hard to give strict timelines on these sorts of things, but really gunning to have it ready for ETHDOM.
And is there any specific proof system that you guys are targeting? I'm really excited about like Plonky 3 and the work done on Binius, for example.
So they work with OptiCode, gives us it's to produce Poseidon hash commitments. We're using PSE's Halo 2 fork to support, I guess, doing that over BN254. I don't see any reason why we can't support other fields as well. But just to start with, it'll be over that.
Cool.
Did you say earlier that you're building an app, right?
Yes. Is a
Do
part
you
of
mind?
the.
Do you mind sharing more about it, or is it not already? Is it just in the initial phase?
Well, right now we're just trying to get the app out into the app store, and the initial use cases is not like solid business. Like problems that we're trying to solve is mostly just to get people excited. So I'm pretty big on Farcaster. So when we release the app, probably like the first frame we're gonna release is like a Tinder, like a performance competition where people can just like compete on their performance on Tinder, which is just more of like a meme thing. But like eventually the goal is to make it like a self-sovereign flag.
Oh, interesting. Thanks for sharing.
Okay. Are there other questions?
I guess I have one question. Is there any challenge that you guys are facing lately that you're trying to resolve? Yeah, just I'm curious about it, like what sort of challenges you might face and how you go about it.
Well, so the biggest challenge for me is because I'm building like a mobile app is like to like deliver a really good user experience, you need fast client-side ZK, and ZK in general has like a million times overhead over just like the regular computation, and so that's like the biggest thing I've been racking my head against for like the past month or so. But recently, I devised a strategy that you can get like a 10 to 20x speed up, and it works like for any proving system. So I'm moving along.
Okay. Then I think we'll wrap up here. But good news, next week there's already another cafe hour, and the topic will be Halo 2. So also interesting for most people who are here today, I think. So thank you very much, and we'll see each other again. Bye.
Thank you, guys.
Thank you.
Thank you for coming. Bye.
Thanks.
Thank you.
Bye.
Thank you.
Bye.
Bye.